Okay, so now let's practice finding and simplifying the derivative for some functions using our shortcut rules that we have. So the first one, f of x equals -5. So in this case, this function is a constant function, so it's f of x equals some value. So because of that, we know using the constant rule then that f prime of x is going to equal to 0. So remember, the derivative of any constant is equal to 0. For the second one, f of x equals x to the 7th. This one just uses our power rule. So f prime of x then. So in this case, our power is 7, so we bring the power down, so this becomes 7. The variable stays the same, so this becomes 7x to the 7 minus 1, or 7x to the 6 is our derivative. For the third one, y equals 5x to the third. So on this one, we have to use the constant multiple rule in addition to the power rule because we have 5 times a power of x. So the first thing we want to do is we want to take the derivative, so we know y prime is equal to 5 times the derivative of the rest of this, so 5 times the derivative of x to the third power. So this is going to be 5 times, and then now working on the x to the third, so bring the 3 down by the power rule. So this becomes 3x to the 3 minus 1. So this is 5 times 3x squared, which then gives us 15x squared for our derivative. Notice on this one, we're using y prime because we have y equals. So your choice of notation is always going to be determined by what you have. If you have f of x, you're going to use f prime of x. If you have y, you're going to use y prime. So because we don't have an f here, an f of x here, we can't say this is f prime of x. You have to make your notation match what your function's written as. All right, let's look at this fourth one. So g of t is equal to 3t squared over 4. So the first thing we want to do is we want to rewrite this because right now we've got a quotient and we haven't talked anything about quotients yet. So what we want to do is we want to rewrite this. So g of t then, just bring out this, write it as 3/4 t to the squared, or 3/4 t to the second power. Now you can clearly see, okay, this is just like the third one. So we have a constant times the function. So we have a constant multiple of our function, so we have to use the constant multiple rule. So we know g prime of t then is going to equal to 3/4 times the derivative of t squared. And so for t squared now, we know, okay, 2 is my power, so I'm going to use the power rule now, bring the 2 down. T stays the same. And then my power now, subtract 1 from it, so 2 minus 1. So this gives us 3/4 times 2t to the first power. And remember, anything to the first power is itself, right? So in this case, t to the first power is just t. And so we can simplify this a little bit. 3/4 times 2, we know is going to be 3/2. So we end up with 3/2 t, or just rewriting it like g of t was written. So g prime of t then is going to equal to 3t over 2. For number 5, so f of x equals 7x. So again, applying our constant multiple rule here. So f prime of x is 7 times the derivative of x. So remember, if you don't see an exponent on this, what is the derivative of that? So this then is x to the first power, right? So remember, if there is no exponent, it's x to the first power. Now be careful, this is not a prime, this is a 1. So derivative of that then, 7, same idea. So bring down the 1, x to the 1 minus 1, or x to the 0 power. So then this becomes 7x to the 0 power, and anything to the 0 power is, that's right, it's 1. So this is 7 times 1, or just 7. So f prime of x then is 7. All right, number 6, p of x equals 3 minus x to the 5th. Now we have a difference of functions here, so we have to use our sum and difference rule. In this case, the difference rule, because we have a difference. So that means, what the difference rule tells us is, okay, so p of x then is going to equal to the derivative with respect to x of 3 minus the derivative with respect to x of x to the fifth. And so now we just differentiate individually, and this is p prime of x. So the derivative with respect to x of 3, so 3 prime, if you want to think of it that way. I don't like saying it that way, but 3 prime, or the derivative of 3 with respect to x. So if we think about it, what type of function is 3? It's a constant. We're using our constant rule. Derivative of any constant is 0. And now, so the next one, so the derivative with respect to x of x to the fifth, using our power rule again. So this is going to be, bring down the power, so 5x to the 5 minus 1, so 5x to the fourth. And then simplifying, cleaning it up a little bit, we end up p prime of x equals negative 5x to the fourth power. All right, number 7, f of x equals 2 over x to the fifth power. So first thing we need to do, we need to rewrite this using our exponent rules on that sheet that's in the Algebra and Trig review section in Moodle. So what do we know? So in this case, exponent in the denominator, we don't want that. We want to write this so that we can use our constant multiple and power rule. So we just need x to some power. So remember to move it up from the denominator to the numerator, or to get it out of the denominator. What we want to do is we want to rewrite this with the negative exponent. So f of x itself then is going to become 2x to the negative fifth power. Remember, anytime you move something over the fraction bar, you reverse the sign on the numerator. So if it's positive, it becomes negative. If it's negative, it becomes positive. So in this case, f of x, we can rewrite this as 2x to the negative fifth power. So from here now, we just proceed like we've done before. So then f prime of x is equal to 2 times the derivative with respect to x of x to the negative fifth power. So by power rule now, bring the negative 5 down. So this becomes negative 5x to the negative 5 minus 1. So negative 5 minus 1 is negative 6. So we have negative 10x to the negative 6th. And do you think you can leave it like that? Do you think we're done? That's right, we're not done. So we need positive exponents, so we got to keep on simplifying. So same idea of how we got that negative exponent in the first place. We want to flip this x to the negative 6th over the fraction bar and make it have a positive exponent. So then this becomes negative 10 over x to the 6th. And that is our derivative. You always want to make sure that you're simplifying your derivatives completely. If you don't simplify your derivatives completely, then you're going to lose points. All right, number 8. So f of x equals square root of x. So in this case, what do we want to do? So we only have a limited number of rules, and none of the rules say anything about a square root, right? So what we have to do is we have to rewrite our square root using our exponent rules that you should already know. And if not, you need to memorize them. They're on that sheet in the Algebra Trig review section. So we can rewrite square root of x as x to the 1/2 power. So then f prime of x now, we just use our power rule. So this becomes 1/2 times x to the 1/2 minus 1 power. And so that's f of x is 1/2 x to the 1/2 minus 2/2. So that you can do this without a calculator, get the common denominator. So that's 1/2 x to the negative 1/2 power. And again, are we done? No, we still have a negative exponent we got to take care of. So let's move that x to the negative 1/2 to our denominator. And so we end up then with 1 over 2x to the 1/2. And you may ask yourself, okay, am I done now? You're still not done. So if you have a rational exponent and the numerator of that rational exponent is a 1, like it is in this case, you need to go ahead and rewrite that in radical form. Now, if your exponent, the rational exponent, does not have a numerator of 1, I am okay with you leaving it in rational form then. So you could leave it. So suppose this was 1 over 2x to the 3/2 power. you could leave it as that, but because in this case our exponent is a 1, we need to go ahead and rewrite this in radical form. So this is 1 over 2 square roots of x. And that is your final simplified version of the derivative. Speaking of rational exponents, now let's look at number 9. So p of x is equal to x to the 2/3 power. So same thing, we just have a power of x, x to some power. So we want to use the power rule. So p prime of x in this case, bring down our exponent, so 2/3 x to the 2/3 minus 1. So that's 2/3 x to the 2/3 minus 3/3 power. So we have 2/3 x to the negative 1/3 power. And just like before, you want to bring this down so it has a positive exponent. So this becomes 2 over 3x to the 1/3 power, positive 1/3 power. And again, because our numerator of this rational exponent is a 1, we want to rewrite this in radical form. So this then becomes 2 over 3 cube roots of x. Now, one thing you don't need to worry about right now, don't worry about rationalizing the denominators. So you don't have to move this radical up to the numerator. I know we taught you that in 171. It's okay. Right now, I'm telling you, you don't have to worry about that. So don't worry about rationalizing the denominator. It is perfectly fine in calculus to have a radical in the denominator. All right, let's look at number 10. So f of t equals 3 cosine t minus 4e to the t. So now we got a bunch of different stuff going on, right? We've got a constant multiple. So we have a constant multiple of cosine t by having 3 cosine t. We have a constant multiple of e to the t having 4e to the t. We have a difference going on. We have subtraction in there. So we got to do all kinds of stuff, right? But it's still not that bad. So if we think about it, so f prime of t, let's take it one step at a time. So that's going to be the derivative with respect to t of 3 cosine t minus the derivative with respect to t 4e to the t. So that's using our difference rule. And then, well, constant multiple rule tells us we can pull that constant out of the derivative. So this is 3 derivative with respect to t of cosine t minus, same idea over here, 4 can come out since it's a constant, derivative with respect to t of e to the t. So that's our constant multiple rule. And now we can use those rules. So we now can use the derivative of cosine x. So derivative of cosine x, or in this case cosine t. So derivative with respect to t of cosine t then is going to be negative sine t minus 4 derivative with respect to t of e to the t. Again, now we can use that basic rule. So derivative of e to the t is itself, it's e to the t. The only function we're going to talk about that it is its own derivative is the natural exponential function. And just cleaning that up, we have negative 3 sine t minus 4e to the t. All right, number 11. So f of theta equals 4 theta minus 5 sine theta. So similarly, we've got constant multiples going on, we've got powers going on, we've got signs going on, we've got differences going on. So same idea. Now this time I'm not going to be as explicit in writing out every single step like I did on the last one. The more you do this, you're not going to literally break it down every single rule every single time like that. You're going to get in the habit of recognizing, okay, I've got a difference, so I can just go ahead and differentiate each term individually. I've got a constant, so it's the constant times the derivative. The more you do this, the easier it's going to come to you. So in this case, f prime of theta is equal to 4 times the derivative of theta. So derivative of theta is, so think again of that as theta to the first power, right? So then that's 4 theta to the 0 power minus 5 times the derivative of sine theta. Well, the derivative of sine theta is cosine theta. So we end up 4 theta to the 0 minus 5 cosine theta. Are we finished? No, we still got to get rid of that theta to the 0 power, because theta to the 0 power is what? 1. So we end up with 4 minus 5 cosine theta for our final answer of f of theta. And the last one of these, so g of x is equal to 5/3 sine x minus 2e to the x. Same idea. We're using multiple rules. We're using the constant multiple rule, the difference rule, and the derivative of sine x and the derivative of e to the x. We're using all of those rules. But again, we're going to do it kind of in stepwise. So g prime of x. So take it first term, right? So difference rule tells us we can do the first term by itself. So 5/3 times the derivative of sine x. Derivative of sine x is cosine x, that's right. So we have 5/3 cosine x. Difference tells us, okay, that it's then still going to be a difference. So minus 2 times derivative of e to the x, which is e to the x. And so we end up with g prime of x equals 5/3 cosine x minus 2e to the x. In this case, there's not really any simplification we can do, so we are finished.